Welcome back. This is part 5 and the last part of the prerequisites chapter, section 1. And this last part we will look at various properties of numbers, of real numbers and of negative numbers, make sure that we have a good grasp on the situation. So first we'll start with properties of real numbers. These first two properties are if you add two numbers, it doesn't matter the order in which you add them, and if you multiply two numbers, it doesn't matter the order in which you add them. This is called commutativity. And for instance, if you took 1 plus 2, it's the same thing as 2 plus 1. That's all that's really going on here. For multiplication, if you took 2 times x, this is the same thing as x times 2. The order that you multiply two things doesn't matter. The next one is a little bit more interesting. This is called associativity. And with this one, this is playing around with order of operations, essentially. So for the first one, if we take a plus b plus c, it doesn't matter if we put parentheses around the a and the b, or the b and the c. The same thing if we're multiplying. If we take a times b times c, it doesn't matter if you put the parentheses around the a and the b and the c. So for instance, if I took 1 plus 2 plus 3, we know that this equals 6, and it doesn't matter if I take 1 plus 2 to get 3 and add 3, or if I take 1 plus 2 plus 3, but I do the 2 plus 3 first, and then the 1. And then the same thing for multiplication. This next one is called distributivity. And the idea here is that we can distribute multiplication across addition. So we can distribute an a across the b plus c to get a times b plus a times c. So for instance, if we took 7 times x plus 2, this is the same thing as 7 times x plus 7 times 2. So whenever you are multiplying after you add two things together, you can just multiply both those things individually. 0 is a special number that we can add by, and 1 is a special number that we can multiply by. These are called identities. And 0 is the additive identity because if you add it to something, it doesn't change it. It preserves the identity of what you added to it. Likewise, if you multiply by 1, it preserves the identity of a. If a times 1 is just a. And then lastly, we have what are called inverses, which essentially undo each other. So if you were to add a to something, you could add negative a to it to get back to where you started, because a plus negative a is 0, and likewise in reverse. For multiplication, we can do the same thing. If I take a times 1 over a, I'm going to get 1. They cancel out. Multiplying by a and multiplying by 1 over a will cancel one another out. Keep in mind that that here a can't be 0 because we can't divide by 0. So these are some good properties of multiplication to keep multiplication and addition to keep in mind. So for instance, in this last one, we know that say 2 times 1/2. We can come back to our list of properties and go, wait a second, 2 times 1/2, 2 times its inverse, and they're going to cancel out, and I'm just going to get 1. Now, most of those only dealt with addition and multiplication, and we didn't see much subtraction and much division. But it turns out that any time that we're subtracting, I can just write it as addition. So for instance, 5 minus 4 is just the same thing as 5 plus negative 4. So I can turn any subtraction into addition. And I personally am more comfortable thinking about things in terms of addition. So this is what I will quite often do. Also, anytime that we see division, we'll just turn it into multiplication. So again, 2 divided by 3, I will normally write this as 2 times 1/3. I called 1 over b the inverse of b a little bit ago. Another name for it is the reciprocal. So, for instance, 1/3 is the reciprocal of 3. 13/7 is the reciprocal of 7/13. And then when we have multiple parts to an algebraic expression, we'll call these terms. So terms are specifically separated by addition, but remember that subtraction is just addition in disguise. So this expression here has 4 terms in it. We've got an x, 6 plus x, a 6 times x, a 3 times y. If I turn this into addition, we'll see that this term is in fact negative 7x and a 3 at the end. So each one of these is going to be a term, and on a given term, the term may have multiple parts. So for instance, I could have a term that's 6 times x times y. The number out in front is called the coefficient. So the number in the front of a term is called the coefficient. So the coefficients here will be 6, 3, negative 7, and 3. Furthermore, we can see that 6x and negative 7x look very similar, and these are called like terms. So like terms are terms with the same variable factors. So coming back up to our example, 6x and negative 7x both have x, and no other term has an x in it. So these are like terms, and they're not like terms with anything else. This has a y in it, and this 3 has no variables here. So the second term, 3y, is not a like term with anything else, nor is the last term. Only the first and third terms are like terms. And we will call an algebraic expression simplified when we've combined all like terms, but we've also removed the parentheses. So just as a quick example, this expression here has not been simplified because it still has some parentheses in it, so we need to get rid of those. So we can distribute. So 6 times the sum of 2 things, that's just going to be 6 times the first one plus 6 times the second. And we've got this. And now when we start this, we go, oh, we still have like terms. We've got a 6x and a 7x. So when we combine these, 6x's plus 7x's will be 13x's. And now we are simplified. So this is in simplest terms here. We've got 2 terms. The coefficients are 6 and 13, and the variables are and the variable factors are going to be x squared and x. The very last thing that we'll see are just some properties of negative numbers. Again, I'm assuming that most of you will have seen this before, but this is just to remind you. When you take a negative 1 times a number, you just get negative that number. So negative 1 times 13 is going to be negative 13. If you take a double negative, these negatives will cancel out. So for instance, negative 3, which we saw in the last part, is just going to be 3. The next 2 are very similar, and this is basically saying that when you have a negative sign floating around, you can put it anywhere inside of the term. So if I had negative 2 times 3, this is going to be the same thing as negative 2 times 3, but it's also the same thing as 2 times negative 3. We can put the negative sign anywhere inside of a term. The last 2 are basically how to distribute negative signs. So here, for this first one, negative, I can distribute a negative across addition. So if I'm taking negative 1 plus 2, this is the same thing as negative 1 minus 2. I can add the negative sign to the 1 and to the 2. It's important to not forget that it has to go on both of the numbers on the inside. And then likewise, if I did the same thing but I had subtraction in the middle, we'll see this double negative pop up. So here, if I take a 1 and if I take the negative sign and I distribute it, I'll get a negative 1 at the start. But now this 2 is going to have two negative signs. It's got the 1 that applies to everything and the 1 right here, and it just becomes a positive 2. And then this last little line is just to remind you that, okay, it doesn't matter what order we add things in, so I might go 2 plus negative 1. And, oh wait, if I'm adding a negative number, it's the same thing as subtracting. So this is just a very quick rundown of some things that you will probably have seen before, but it's good to reinforce these things because we'll be using these all semester. And that will conclude the prerequisites chapter, section 1.